So today we will learn about influence line. Basically today we will draw the shear force diagram or influence line diagram for shear force. In our previous video we learned ILD for reactions. Today we will learn ILD for shear force and moment also. Okay, so let's take a simply supported beam. This is the AB and this is L distance. Now we'll take 1 unit load at a distance of x. Okay, now we have to draw, and the middle point of AB is P. So now if we the reaction for means if we have to find the shear force at point P, shear force, if x is less than a, means x is less than a, the value, this is A and this is B. So for x less than a means in the left hand side, what will the value of shear force? It will be what RA minus 1. Are you getting? Because RA is in upward direction and 1 is in lower direction, so it will be RA minus 1, and RA minus 1 is equal to RB. Yes or not? Because RA plus RB equal to 1. So and the value of RB, we had already calculated the value of RB in our previous video. You can see it from previous video how to find the value of RB. The RB value is x by L, and this value is actually RA minus 1 is minus RB. It will be minus x by L is minus RB. Minus RB, because RA plus RB equal to 1. So RA minus 1 equal to minus RB. Okay, and the shear force for x greater than A, its value is equal to, for x greater than A means here the value will be RA. Yes or no? Because if x is the load will be something there, so shear force at P, this will be the only force. Okay, and the value of RA is L minus x by L, which you can see from our video how to find the value of RA. Okay, now we have to draw the ILD for shear force. ILD for RA. What is the ILD for RA? If we have to draw the ILD for RA, means at x equal to 0 and at x equal to L, what is the value of RA? In here I had only calculated the value of, this is a shear force at x equal less than A and shear force is greater than A. Okay, so the value of RA means ILD for RA is this one. This is the ILD for RA. ILD for RA, there is, this is 1 and this is 0. How to find ILD for RA? We had discussed in earlier videos. And I had to find the ILD for RB. This is the ILD for RB. This is negative and this is positive. So to find the ILD for shear force at point P, this point P. So which part we have to take? This part and this part. Okay, this part and this part. So finally, what is the shear force for shear force, or the ILD for shear force? It will be something like this. Yes, and this is the positive value, this is the negative value. Now what is the distance of these two? The overall distance of this is 1, and for this means shear force are equal to A. This is A point, actually distance A. So putting A in this equation, if we put for array, this array, and this is the ILD for array. So for array, putting x equal to a, its value will be means shear force at x equal to a, L minus a by L. If overall value is 1, if and this value is L minus a by L, then this value is a by L. The value is a by L, but as it is in negative direction, in negative part, so it is minus a by L, but its value is a by L. Okay, so don't confuse. So this is the ILD for shear force, and ILD for moment. Now we will calculate the ILD for moment. What will be the moment at P? Moment at P, if x is less than a, what will be the moment at P? Moment at P is equal to what? One is array into this a, array into a, minus 1 into a minus x, 1 into overall is a, and this is the x part, so 1 into this will be a minus x. So a into array into a minus 1 into a minus x means array into a minus a plus x. So this value is equal to RB into B. Yes or no? Because at this point the moment is array into a minus 1 into, and this is a moment at P, and if you take see from this side, so if you on this side, then what is the value? RB into B. This is equal to RB into B actually, because we had we know the value of RB. RB is minus RB is x by L, so we can put x by L into B. That's why we can also do by array if we know the value of array, but here RB is we know my x by L. That's why so what is x? If at x equal to a, at x equal to a, and P is AB by L. And similarly moment at P, if x is greater than a, then what happen? If x is greater than a, then it will be array into a. Similarly, same. You're getting? Moment at P, if x is greater than a, then it will be, if you see this part only, then what is the value? Array into a. Okay, so what is the value of array? We know the value of array, that is L minus x by L, L minus x by L into a. And if we put x equal to b, x equal to b, x equal to a, at x equal to a means L minus a by L. L minus a means AB by L. Are you getting? Means moment at x equal to a is AB by L. L minus a means B. Are you getting? So what will be the ILD for moment P, at section P? What will be the moment? The value is AB by L. So it will be, and this value will be AB by L. Are you getting? This moment at P is AB by L. Are you getting? So this is the way how to find ILD for shear force and bending moment. I hope you are getting. So in next video we will learn influence line of trusses and overhanging beam also. Thank you.